Hello, Dr. Rauscher here. All right, let's go over another problem. Here we're looking at the isotopic notation of elements, since we have these symbols here, and from these symbols we can then find out how many protons, neutrons, electrons there are, and we can figure out the mass number, okay? And from that information that we have over here, we can then figure out what the isotopic notation is. First, let's go over what is isotopic notation. So we have this, we'll call that X. This here would be Z. We have A here, and we'll just call this a C. Okay, those are the three different elements up in that isotopic notation. X is just the chemical symbol for the element, right? A is our mass number. And this is just the number of protons minus the number of neutrons. I'm just going to put a symbol for number, and I'm just going to say N here for neutron. Okay. Then Z is our atomic number. And this is just the number of protons. All right. C is the charge. Okay. The charge on the isotope. This is just going to be equal to the number of protons minus the number of electrons. Okay. All right. So let's figure this out. For this isotope we have here, aluminum. Now, it's interesting that they actually give us the atomic number, because the atomic number is defined by the chemical symbol as well. So if you look at aluminum is the atomic number 13. And so it has to have a 13 there. It can't be Al if it doesn't have a 13 there. So the number of protons here is 13, because that's our atomic number. The number of neutrons then, well, that's just going to be 27 minus 13, right? And 27 minus 13 is going to give us 14. So we have 14 neutrons plus 13 protons. This is going to equal 27, right? How many electrons do we have? Well, the number of electrons and the number of protons need to be equal for a neutral compound or isotope. In this case, this isotope has a +3. So as I said here, that the charge +3 is going to be equal to the number of protons minus the number of electrons. So the number of electrons then are going to be the number of protons minus the charge, right? Okay, so in this case, then that means that there's going to be 10 electrons, right? So we have 13 protons minus the 3 gives us 10. So what's the mass number? Well, mass number is what we already decided is already given to us as A, right? The mass number. So that's going to be 27. Excellent. Now, how about here, carbon 14? Well, come back here to the periodic table. Carbon is 6. It should have a 6 here, and it does. It better have a 6, because otherwise something's wrong. So that means then that the number of protons is 6. Okay, the mass number is 14. Why don't we just go ahead and put that there? That's easy. 6 minus 14, well, that's going to give us 8 neutrons, right? Or sorry, 14 minus 6 is going to give us 8 neutrons. Since we have no number here, that means there's no charge there. And so the number of electrons needs to be equal to the number of protons. It's going to be 6 as well. And we're done with that column. All right. So in this case, let's go ahead and do this one. This one's pretty easy because it's already given us a number of protons. Number 7. Let's look at number 7 on the periodic table. Number 7 on the periodic table is nitrogen. So we're going to put an N here. All right. We know that it has a 7 there. That was already given to us. The mass number we're told is 14, so we can just write that here. Well, now to find the number of neutrons, that's just going to be 14 minus 7. And it's going to be 7. and we're done. Wait a minute, we're not done, because look, it's got 10 electrons, but only has 7 protons. Well, so 7, 8, 9, 10, that means there's 3 extra electrons, which means that this is going to have a -3 charge. Okay. All right. The next one here, we have an element that has a mass number of 70. It has 30 electrons, and it has 39 neutrons. Well, what element is it? I don't know how to tell what element it is. It's real easy. We can figure out what the number of protons are by taking the mass number and subtracting the number of neutrons from it, right? So 70 minus 39 is going to give us 31. So we have 31 protons. I'm just going to write my 31 here. And if I look at my periodic table and figure out where's 31, well, that's gallium. So I can give it the symbol Ga. All right. Now, a lot of students, for some reason, when they want to put this mass number here or the mass number there, they look at the mass here, but this is not the same thing as the mass number. That is actually the weighted average of all the isotopes of gallium on Earth. So we can't use that, right? That's the atomic mass, the molecular mass of this compound, not the mass number, the atomic number. It's the atomic mass, not the atomic number, right? So, so then what we're going to do is to get the mass number is we're just going to write the number that we have right here, there. So now we have gallium 70 and 31. Are we finished? Not exactly. See, we have 30 electrons and 31 protons. That means we're short by 1 electron here, meaning that this will have a +1 charge. Being short by 1 means it's going to be positive, right? It's -1 negative charge. So that's going to be a positive charge. All right. Hope that was helpful.